Okay, let's clean up IQR, or interquartile range. Got a little bit off track at the end of that last video, and so I thought it'd be a nice idea to maybe clean this up a little bit. So this is our interquartile range. I'm going to go ahead and start with those same numbers that I used before. So let's see, what do we have? 1, 1, 2, 3, 3, 4, 5, 7, 7, and 8. And again, we want them sorted when we look for median or quartiles or something like that. And the quartile is just the median of the group that's left after I've found the median. Okay, so in this case we have 10 numbers. So I'll try not to screw this part up like I did before. So here's the order of my numbers and their rank within the data set. And so since there are 2 numbers that we need to take into account, right? So we split our data set. If we were to find the median, we would go in here and we would look at 3 and 4, and we'd say, oh well, the median is the average of those 3 plus 4 over 2, which is 7 over 2, or 3.5, 3.5, and again, the idea is, if I have an even number in my data set, even number of numbers, so here I had 10, when I split the data set in 2 to try to determine that median, I will truly do that. I'll split the data set in 2, and what we'll do is, in order to get our interquartile range, we will say that we're going to take this whole half. We're not going to get rid of that 3 nor that 4 that we used in finding the median. We aren't going to get rid of those. We're going to take that whole half, and we're going to compute Q1, the first quartile, and the median, by the way, is the second quartile. 50% of the numbers are on each side. Here, quartile, we want about 25% on each side. So Q1 is the median of this side. And so we can look here, we see that 2 is the middle number, and so Q1 is equal to 2. Same thing here. Q3, the third quartile, is the median of this side. Okay, so we have that, and in that case that's the 7, so Q3 is 7. And then once we have those, our interquartile range is just the difference. It's the middle 50% of our data. So Q3 minus Q1. It's really, one way to look at it is it's the range, interquartile range. So it's finding the range that encompasses the middle 50% of the data, and so we have our 7 minus 2 is 5. Okay, so that's our interquartile range. No more difficult than that. Now let's take away one of those numbers, so I only have 9 numbers, and I believe that was 1, 1, 2, 3. I think it was 3 again. No, it wasn't. It was a 4, I bet. No, it was a 3 again. Okay. 4, 5, 7, 7. And we'll stop there. We won't put that 8 in there. And this will be 9 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So here, when we do this and we find the median, it will be just that middle number, 3, 4 on each side of it. So here the median is equal to 3. And now when we find the Q1 and Q2, in this case, we'll take that half and this half. In other words, since the 3 is just all by itself in the middle here, the median in that case, we just won't bother with it, and we'll take the half on each side. And so in this case, to get our Q1, we need 1 plus 2 over 2, or 1.5, because it's the median of those 4 numbers. Similarly here, Q3 is 5 plus 7 over 2, because it's the median of those 4 numbers. And that's 12 over 2, or 6. And so in this case, our IQR is equal to our Q3 minus Q1, which is 6 minus 1.5, or 4.5. Okay, so those are our methods for calculating IQR. You know, we either, if there are an even number of numbers, then we'll truly take half on each side, half on that side, half on this side, and find the medians to get our Q1 and Q3. If we have an odd number of numbers, we'll find that median there, but then just take everything that's left in order to find our Q1 and our Q3 here. So there you go. That is interquartile range, and what's nice about it is it really doesn't change a lot by just adding usually a single piece of data. Or, you know, suppose back in the problem up here, suppose I change that 8 to a 1 million. Actually, it wouldn't change the median nor the interquartile range by changing that 8 to 1 million. But it would substantially change the average, and also and because it substantially changed the average, it would also change the standard deviation. So if you need measures that are very, very stable and don't really care much about really wild numbers, what many would call outliers, that kind of thing, then you probably want to go with things like median and interquartile range. But you know, for other applications and much of what we do in this course, we're going to be using the mean and standard deviation. But I think it's important to kind of see that there are various measures of centrality, you know, so 2 of which are mean and median, and various measures of dispersion, 2 of which are standard deviation and interquartile range. All right, so that'll do it for interquartile range.